Hello, class, and welcome to Laboratory Activity 4.2, Solubility Curves, and this is Content Lesson 2. And so we're dealing with the same major understanding from the previous content lesson, which is that a solution is a homogeneous mixture of a solute dissolved in a solvent. The solubility of a solute in a given amount of solvent is dependent on the temperature, the pressure, and the chemical natures of the solute and solvent. So previously we talked about the chemical natures of solute and solvent. Today we're going to focus particularly on temperature and how that impacts solubility. Okay, and so for solubility curves, we have in the New York State Chemistry Reference Table, Table G, solubility curves, and there are numerous chemicals on that curve. However, I distilled it down to just looking at two of the chemicals on the table. Okay. And so first, we're going to talk about solubility of gases. Okay, and so for solubility of gases, our solubility decreases as temperature increases. Okay. And so if you notice on this table G, we have one of our substances as the temperature increases for the solution, the actual solubility or the amount of grams of solute per 100 grams of water decreases. And that's for NH3. And the reason being is NH3 is a gas. Okay. So on the table in the New York State Chemistry Reference Table, there's actually two other curves that follow the same pattern. That is, temperature increases, solubility decreases. And so the three substances that show this trend are NH3, HCl, and SO2. And the reason they show this trend is because they're gases. Okay. So now the remaining compounds listed on the table are solids. And so generally, solubility increases as temperature increases. Okay, and so on our table G here, I provided a sample curve of a solid, and that would be ammonium chloride, NH4Cl. And you can see as temperature increases, the solubility of NH4Cl also increases. Okay, so now what we're going to do is we're only going to consider NH4Cl or ammonium chloride. And by the way, ammonium chloride is a solid, so that's the reason why it shows this trend that as temperature increases, solubility increases. Okay, and we're going to consider just NH4Cl, and we're going to consider the temperature of 80 degrees Celsius and these three specific points on table G in relationship to the NH4Cl curve. Okay, so we're going to kind of ignore ammonia for a second and just focus on this one curve here. Okay. So if we're looking at position A here, okay, if we were to read this table correctly, we'd say at 80 degrees Celsius, position A has 42 grams of solute. Okay, so it'd be 42 grams of solute in 100 grams of water. Okay, so this entire table is how many grams of material or of a substance will dissolve readily into 100 grams of water. So for this table, water is our solvent, and we're dealing with the same mass of water each time. Okay, so now if we were to consider this point on table G in relationship to the curve of ammonium chloride, so if we had 42 grams of ammonium chloride at 80 degrees Celsius, well, now this point is below the curve. Okay, so because this point is below the curve, we would say that this solution would be unsaturated. Okay, and another term we could use instead of unsaturated, we could say that this solution is dilute. Okay, so unsaturated solutions can generally be referred to as being dilute. Okay, and so point A would be unsaturated. Okay, and what that means is that you could add more solute to our solution and it would dissolve readily. Okay, so what we could say is that an unsaturated solution has less than the maximum amount of solute. Okay, so less than max. Okay, now for position B is actually right on the line for the curve of NH4Cl. Okay, and so we could say for position B we have about 65 grams of solute. So we could say there's 65 grams of solute in 100 grams of water. Okay, and now because this point is directly on the line of the curve, this would represent a saturated solution. Okay, and so B represents saturated. And so what that means is that we have the maximum amount of solute added to our solution. So we cannot add any more. If we did, the particles would settle to the bottom of our container. Okay. And then the last position in relationship to NH4Cl is actually above the curve. Okay. And so for this position, we could say that we have about 95 grams of solute in 100 grams of water. Okay, and so because this point is above the curve, we would say that this is a supersaturated solution. Okay, so this solution would be supersaturated. So at point C, we have a supersaturated solution. And what that means is we actually have more than the maximum. Okay, which is kind of a difficult concept to understand, but it's possible if we heat up a solution and then add enough solute that it becomes saturated and then allow it to slowly cool, that we can actually dissolve more than what would be considered the maximum amount of solute. And so in those scenarios, you end up with what's called a supersaturated solution, which would be more than the maximum. Okay. So a more generic terminology than saying saturated solution or supersaturated solution is we could say that both position B and position C represent concentrated solutions. Okay. And it's also important to note that since this table represents the amount amount of solute per 100 grams of water, that if we had 50 grams of water, we would have to take every value on this table and divide it by 2. And if we had 200 grams of water, then we'd have to take any value we find on this table and multiply by 2 or double it. Okay. And so today we talked about solubility curves. We talked about how gases show a decrease in solubility as temperature increases, and that on table G, NH3, HCl, and SO2 are gases. And then we also talked about how solids on table G show increase in solubility as temperature increases. Then we specifically talked about the curve for ammonium chloride and how a point below the curve on table G would represent an unsaturated solution for that substance. A point on the curve would represent a saturated solution for that substance, and a point above the curve would represent a supersaturated solution for that substance. Okay, and so that is lesson 2, and I will see you for lesson 3 tomorrow. Thank you.